Friend Finder, Make Your Friendship Tangible, presented by Yu Bo Chen, Hayden Yan, Zeyu Hu, and Robert Wan. So, what is Friend Finder? Have you ever worried about you having no friends? Or do you often question whether the friends around you are truly your friends? Well, the answer is probably yes, because you are a miserable computer science student. But don't worry, we've got you covered. Friend Finder is a revolutionary tool that helps you to quantify your friendship based on your social media activities. For each person inside your social network, we generate an index that demonstrates how likely you and that person will become friends. With these numbers at your hand, all your friends-related questions will be solved once and for all. So how do we do that? Based on extensive social science research, we took two major components into consideration, the interpersonal likeliness and the networking positions. And the interpersonal likeliness describes like how similar you and your potential friends are as people using the personalities from both of you. This category focuses on purely the interpersonal relationships without external influences. And the networking positioning, it describes whether you and your potential friends within the same network. This part focuses solely on the social aspects and ignores any personal likeliness.
Well, from social science, we know that there are 16 different personality types of people in the world. This is called MBTI personality types. And we have a dataset that consists people's comments on social media and their corresponding personality types. From this dataset, we can train a base model and do further classification. First of all, we have to pre-process our dataset into a more sensible one. And we want to keep only English characters, English words from A to Z and the numbers from 0 to 9, and then transfer those English characters into lower cases. For each different personalities, we can have different statistic result. And we group by different personality from their input, and we have the word cloud. For different personality, the keywords are different, and this is one of them. Also, we can get the composition, the ratio of different types from this data set. And this gives us insight into our data set, as well as the words per comment. From this figure, we can safely say that ESTJ people would like to use more words per comment than ESFJ and then ESFP, as well as the density per word of each word. Computers can sometimes be stupid. They can only intake some numbers. And what we have is text and words. So this is where TF-IDF come into use. It uses the frequency and the importance of each word and build up the vectors and the matrix as the input for the model training. As for model selection, the best one is linear SVC. It gives us the accuracy of 0.67 on accuracy, and we have trained many other traditional models, but none of them surpass this result, as well as neural network. I guess this is because our dataset is relatively small, so this is why neural network didn't perform well on this dataset.
The goal of networking is to classify Twitter users by how influential they are. We will cluster Twitter users and then build our network. The model we use here is K-mean. K-mean is an unsupervised learning method, and it takes all numerical values. So we will process the raw data set before training it. Our raw data set like this, as you can see, it has a lot of fields, but we will only take some of them. We will use PySpark to do a series of ETL operations to the dataset, such like removing all null values and typecasting. And we will also use a PySpark function called dateDiffer to calculate the active date of that user. And now we have our dataset like this. We can put it to the K-mean mode. And next, I will let Hayden to introduce K-mean mode for you.
We want to classify the data into 15 distinct groups. The intention is, we want to assign an influential ranking to each group. Because the dataset doesn't include labels, we need to use an unsupervised clustering method to handle this problem. Since the range of data in each feature varies from tens to thousands, it is critical to normalize the data so that the data points fall into the range from 0 to 1, as the clustering algorithms use distance-based measures to evaluate the similarity between data points. We are also facing to a large dimensionality problem. Visualization is challenging this way. It is a common practice to use principal component analysis before clustering algorithms. PCA is a dimensionality reduction technique which reduces the number of variables of the training dataset, but then the information is preserved as much as possible. So after feeding the data to the model, we can classify the entire dataset into 15 groups. We want the predicted outcome to be the groups along with the numerical number of the centers, and each group assigned to an influential ranking score from 1 to 15. So with the most ranking score, the person in this group is considered as the most influential. Let's say there is a new incoming record. The person has only a few followers, followings, and post count. So since the data is small, the person is expected to be labeled to a group with low ranking score.
We prepared a simple interactive demo to show exactly what we have done. Here's a simple network. Each node represents a person, and nodes are connected by arrows, which represent the common areas of interest that they have. Those who are not connected means that they do not share any area of interest in common, at least not on social media. Let's use Jack and Ella as an example. Jack and Ella. So Jack and Ella, they share 3 out of 4 MBTI traits, so their personality is very similar. Both of them are relatively influential in the network and share common interests, so the possibility of they becoming friends are very high. On the other hand, Bob and Richard, let's use Bob and Richard. And Richard. The Bob and Richard, they are both kind of antisocial and distant personality-wise, so they are less likely to become friends. If you are Bob, don't worry. Here's a list of friend possibilities in your network. Check out those who have high scores with you. Those are potential friends. The one last pair that I wish to show is Jack and David. Jack and David. Yes. So Jack and David, although they're not connected, they are not connected on the graph, but they have extremely high friend possibilities. This is extremely important because traditional recommendation systems, which based on common interests between people cannot discover the likeliness between those two who do not share anything obvious in common. However, we focus on the humans and is able to make truly personalized recommendations. With Friend Finder, we see beyond the obvious connections and break the information cocoons that other recommendation system could not. We're more than happy to answer any question that you may have, but unfortunately it's not possible for this presentation. Here are some questions that we believe you might be interested in, and we'll be asking those questions for you. First, what are the big data tools used in this project? Big data tools, we used to have 2 major categories, the data storage tools and data processing tools. Our data is usually stored on AWS S3 bucket, which is a relatively budget option and can be configured to be publicly accessible. Data processing tools are mostly Spark on EC2 instances and Pandas if running on locally. Spark is useful when applying simple preprocess to huge amount of data. Combined with the superior computational power of EC2 instances, we can comfortably process larger amount of data that is not possible with our own laptops. Pandas come in handy when doing complex data processing on a smaller scale for specific downstream tasks. All these tools greatly alleviates big data problems. How are we going to handle larger than expected amount of data? Besides adding more machines, we could adopt message queue to process data as they come. We could also train our models in batches so they can be trained faster. As we may also migrate to the big data platforms with load balancers that can use our machines to their fullest extent. What are some real-life applications of this project? Well, people sometimes do not reach out to make new friends because they're so afraid of being hurt, or other people who are so different from them may not understand them in many aspects. But what if they can reach out to the one nearby who is similar? Friend Finder comes to help. The combination of social science, psychology, and data science will make our social life easier than it was and avoid some mental issues result from solitude. And we are all terrible computer science students with zero socializing abilities. So we can also benefit from the pairing system of romantic issues result from our Friend Finder. And that's it. Thank you very much for the listening.